Okay, so in this one, we're going to have to do a little bit more math, and you guys can all have different answers for this. It's just depending on how your graph looks. So for this one here, my different options, I can assume that this little dot here, that could be the max. If I do that, and then I make it look like this, I could say that that is a cosine graph. Alternatively, another option that I've got, I could say that that is going to be also a cosine graph, assuming this point here, and then I could go down like that, assume that it goes all the way down like this, and then kicks back up. I could assume that that is, what else could I do? I could assume that this little point here is my maximum, and then I would have to work out, what my graph is like that. So you can make a couple of different choices just based on your understanding about sine and cosine graphs. So for me personally, I think the easiest way for me to do this is to assume this point here and then go down. So I'm going to assume that here is the max, here is the min, and then after this point, I'm going to say that this subscribers thing will go back up. If I'm going to say that a trigonometric function is the best, then I am assuming that this person's subscriber rates are going to oscillate between whatever your equilibrium value is, or your middle one, or your D value, as we normally call it. Okay, so here is our function, y equals a. Now, this one's going to be a cos function, cos b bracket x plus c bracket plus d. Now, if I am going to, actually I think we normally have minus c in there. Either way, I'm not going to say that there is a c value. So therefore, no phase shift. C equals 0. So the first thing I'm going to do is knock him out. Otherwise, you'll have to solve for him using actually, you won't have to solve for him using things. If I was going to say my C value was there, then I would assume that this point here is the C. So I would say 2.5 or something. But this is going to make my life a little bit easier. So now we're going to do the next one. So we are going to find the D value. So in order to find the D, I'm going to do the max plus the min divided by 2. Okay, it's just the average. So our maximum value there is 5500 plus our minimum value 5450 divided by 2. That's going to give me 10950 divided by 2. If I chuck that in a calculator, I'll get 5475. So 5475 is going to be our equilibrium value. Now, it is early and the coffee hasn't sunk in, so we're just going to verify that that is, in fact, a true thing. 1090 divided by... That's right, that's why they pay me the big bucks. Okay, so that's what we're doing there. So that's our D value. So therefore, now I can assume this in the model. Y equals A sine... Sorry, not sine, cos. Why is it cos? Cos it is. Ah, so funny. Cos B X plus 5475. Now, the next piece of information that I can read off the graph, because I've said that it's 5475, so that's where our D value is. Now I can work out what A is. A equals your max minus D. So it's going to be 5500 minus 5475, and that's going to give you 25. So now we know therefore, now we've found y is equal to 25 cos bx plus 5475. Next value that we're going to assume is b. Now, to calculate b, normally we would do the period is equal to 2 pi on b. So if you use the reverse fact, b is equal to 2 pi on the period. Now, I don't have the full period, but I have half of the period. So half of the period is equal to, let's assume this point here is going to be 11. Oh, it is 11. So half of the period is equal to 11. So that means one period is going to be equal to 22. So here we're going to have 2 pi over 22. When they cancel out, it's going to work out to be pi over 11. So therefore, the model that we've developed for this thing is y is equal to 25 cos pi t on 11 plus 5,475. Now we can graph that in Desmos to see what happens. Okay, so y2, now we're just graphing it against those points so that we can use our regression analysis to see how well this fits the data. So 25 cos bracket pi, all you have to do to get pi in there is start typing pi, x2 divided by 11 bracket plus 5,475. Oh, look at that, beautiful. Now it hasn't 100% assumed the position of that, but you know, it's not bad. Regression score of 0.74. I can live with that model. So that's the model we're going to roll with. So I would state that, yes, that is the correct model. Another thing that I haven't been doing, but you could also do, is you can add in just a basic regression score to see what the optimum values would have been. So to do that, I just type the function again, but I leave the variables in there, and then underneath, it will tell me what the best case was. So b x2 minus c. You'll have to verify on the thing whether we've been using plus c or minus c. I just can't remember. It's just too early. Okay, so it's saying that that would be the best one to use. Now, for their one, if I zoom out, you can see that they have chosen to make that a really small portion of the graph, which is something you can totally do, but it just probably isn't what is going to be the best model for this assignment. But you can see, if I keep scrolling down, then that's what they've done. They've just zoomed out, or zoomed really close in, assumed it to be just a teeny tiny portion of that. And what that really says to us is that the best model for this is probably a linear model. Okay, so take a screenshot of this bitty with that bitty, and then you'll be ready to derive.